Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Thiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series B.Arc Mathematics Semester 1 Lecture 15. In this lecture, we are going to see standard deviation and variance, regression and correlation. The standard deviation and variance are terms in statistical methods. The standard deviation talks about the deviation of the data from the origin. Then variance talks about the variation of the data from the origin. Then regression and correlation. These are all the concepts we are going to learn in this lecture. Standard deviation. The standard deviation is the most important and the powerful measure of dispersion of the sample. This dispersion can be computed using a formula. So, it is computed as the square root of the mean of the squares of the difference of the variate values from their mean. So, to learn to get the standard deviation, first we need to get the mean of the sample. From the mean, how the samples are deviated can be learnt using the standard deviation formula. So, thus standard deviation sigma is equal to square root of sigma fi into xi minus x square over n. So, this is the formula to calculate the standard deviation. Here this n is the total frequency of this summation of fi, total number of frequency of summation of fi. If however, the deviations are measured from any other value a instead of x, it is called the root mean square deviation. So, in standard deviation itself another kind is there, that is called root mean square deviation. Here instead of the mean, some other value is assumed. From that value, how the samples are deviated, that is learnt by this root mean square deviation. Then the next thing is variance. Variance is related to standard deviation. The square of the standard deviation is known as variance. That means if standard deviation is multiplied 2 times, you will get the variance. So, variance sigma square is equal to sum of fi into xi minus the mean whole square, mean by n the whole square. This is the formula to calculate the variance. Now, let us come to the calculation of standard deviation. Earlier you learnt the definition of standard deviation. It says that it is computed as the square root of the mean of the squares of the difference of the variate. It can be calculated by 2 methods. One is shortcut method, then other one is step deviation method, as we have calculated the arithmetic mean. Here the change of origin and the change of scale considerably reduces the labor in the calculation of standard deviation. So, in the group of data given, first we need to change the origin and the scale of the data. Once we did that, we have simplified the calculation of standard deviation. then we can apply the given values in the formula. First method is shortcut method. Sigma is equal to square root of sigma fi di square over sigma fi minus sigma fi di over sigma fi the whole square. So, this is the formula to calculate standard deviation in shortcut method. Here this I can take any values between 1 to infinity. In step deviation method, the step value should be included. Here h is the step value or h is the equal class interval. The formula for standard deviation in step deviation is sigma is equal to h into square root of sigma fi d dash square, where this d dash is computed from this formula. D dash di dash is equal to xi minus a by h, where this a can be any arbitrary origin, then xi is the arithmetic mean. So, standard deviation in step deviation method is sigma is equal to h into square root of summation of fi di square over summation of fi minus summation of fi d dash I over summation of fi d square, where this di is equal to xi minus a and d dash I is equal to xi minus a by h. This is the assumed mean and h is the equal class interval. From this standard deviation calculation, following observance is done, that is, the root mean square deviation is least when measured from the mean. You know, the standard deviation can be measured apart from the mean by choosing any arbitrary origin. If the mean is the origin, then the root mean square deviation is least. That is the observance we made in the calculation of standard deviation. Then the root mean square deviation can be computed using this formula, that is S square is equal to summation of fi di square over summation of fi. This is the root mean square deviation. Here this summation of fi di over fi is equal to a plus summation of fi di square over summation of fi minus a is equal to x minus a. So, this is how the root mean square deviation is obtained in the standard deviation. Then from the shortcut method of standard deviation, you learn two methods to calculate the standard deviation. One is shortcut method and another one is step deviation method. From the shortcut method of standard deviation, this S square is nothing but the root mean square deviation is equal to sigma square. The sigma square is variance plus the arithmetic mean minus the arbitrary origin. So, S square is equal to sigma square plus x minus a. This shows that this S square is always greater than the sigma square, and the least of this value is S square is equal to sigma square. That means if this x minus a is equal to 0, S square is equal to sigma square, that is the least value for this root mean square deviation. This least value will come when the mean is assumed as the origin. Suppose some other origin is assumed, then this root mean square deviation will always greater than the variance. That is the observation from this root mean square deviation. The next thing is coefficient of variation. You know, the square of standard deviation is variance. How that variance can be numerically calculated? Using this coefficient of variation. This coefficient of variation is defined as a ratio of two terms, that is the ratio of standard deviation to the mean. You know that standard deviation is sigma, mean, geometric mean is nothing, arithmetic mean you know x1 plus x2 plus x3 etc. xn over n, that is arithmetic mean. Geometric mean is power to the power 1 by 2. So, the coefficient of variation is the ratio of standard deviation to the mean, that is sigma into root x is known as the coefficient of variation. As this is a ratio having no dimension, this coefficient of variation is used for comparing the variations between the two groups with different means. So, you are given two group of data, mean of these two group of data are different. You want to compare the two group of data. In that case, you can go for the coefficient of variation. This coefficient of variation is the ratio of standard deviation to the mean. So, this coefficient of variation is used to compare the two group of data. Now, apply this standard deviation and variance in the following example. Here in this example, the score of two batsmen are given, batsman A and batsman B, in a series of innings. Which batsman is better scorer and who is more consistent? Statistically, we need to predict based on their scores in different innings. Batsman A scored 12, 115, 6, 73, 7, 19, 119, 36, 84, 29. That means he went for maximum and minimum, very low as 6, maximum as 119. Like that, batsman B scored averagely like 47, 12, 16, 42, 4, 51, 37, 48, like that. His score is average and standard. Based on these two data, by seeing the data we can't predict this batsman is better scorer and this batsman is more consistent. Only doing some statistical analysis we can predict batsman A is better scorer or batsman B is better scorer, like that. To do that statistical analysis, first we need to calculate this D and delta, all those things, D square. For batsman A, x is the score of batsman A, then D is the thing for deviation for batsman A, and D square, this component is squared, then y is the score of batsman B, and delta is the deviation of batsman B, and delta square. Then this gives the sum of D square for batsman A, and this gives the sum of delta square for batsman B. Using this table, we can calculate the standard deviation and variance. By knowing the value of standard deviation and variance, we can predict this batsman is the better scorer and this batsman is more consistent, like this. For batsman A, the arithmetic mean x bar is equal to 51 plus summation of D over n, which is equal to 51 plus 10 over 10, which is equal to 50. So, for batsman A, the arithmetic mean is 50. Now, go for the standard deviation of batsman A. Let us keep that as sigma 1. Standard deviation of batsman A is sigma 1, which is equal to square root of summation of D square over n minus summation of D over n the whole square. So, this is the formula to calculate standard deviation. According to the table, this summation of d square for batsman 1 is 1000, 17,508. Then this n is nothing but 10. So, this will become 1750, that is 1750.8 minus 1 the whole square. The summation of d over n gives the value minus 1, that is squared. We got this. After simplification of this, the standard deviation for batsman 1 came as 41.8. This is the standard deviation for batsman 1, batsman A. Now, coefficient of variance, coefficient of variation for batsman A is equal to sigma 1, that is standard deviation over this x into 100, which is equal to 41.8 over 50 into 100, which gave the value 83.6. So, this is the coefficient of variation for batsman A. Now, let us go to the standard deviation and coefficient of variation for batsman B. Standard deviation for batsman B, sigma 2 is equal to square root of summation of the delta square over n minus summation of delta over n the whole square. This is the formula to calculate standard deviation for batsman B. Now, arithmetic mean we are in need. The arithmetic mean of the batsman B is y bar is equal to 51 plus summation of delta over n, which is equal to 51 minus 240 over 10, which gives the value of 27. So, arithmetic mean of batsman B is 27. Now, compute the standard deviation for batsman B. That standard deviation is equal to square root of 930.2, that is 9302 is divided by 10, you got 930.2 minus 24 the whole square, which gives the value of 18.8. So, standard deviation of batsman B is 18.8. Go for the coefficient of variation for batsman B. The coefficient of variation for batsman B is equal to 69.6. So, the coefficient of variation for batsman B is 69.6. Coefficient of variation for batsman A is 83.6. So, from this coefficient of variation, you can say that that batsman B is more consistent than the batsman A. Coefficient of variation talks about how his run is varying from the mean value. Here for batsman A, the coefficient of variation is very high, that is 83.6. For batsman B, the coefficient of variation is 69.6. So, batsman B is more consistent. Then coming to the standard deviation for batsman A, the standard deviation is 41.8. For batsman B, the standard deviation is 18.8. So, the batsman A is a better scorer than batsman B. Based on the standard deviation, the best of a person or a sample can be predicted. Based on the coefficient of variation, how consistent a sample can be considered. This is how you can apply the standard deviation and variance in the analysis of data. The next concept is correlation. There are many phenomena where the change in one variable are related to the change in other variable. So correlation comes into picture. This correlation gives the change in one variable with respect to other variable. Example for that changes are the yield of a crop varies with the amount of rainfall. Like that, the sale of a product depends on the amount of availability of the product. If the product is available abundantly, then sale of the product will be more. If the product price is very high, then sale of the product will be very less. Like that, two variables can be related. That relation is statistically analyzed by the correlation. Such a simultaneous variation, that is, when the changes in one variable are associated by the changes in other, is called correlation. This correlation can be of two types, that is positive correlation and negative correlation. Then the data involved in the two variables is called bivariate population. Such a data connecting these two variables is called bivariate population. Then the types of correlation, positive correlation and negative correlation. If an increase in the values of one variable corresponding to the increase in the other, the correlation is positive. Similarly, if an decrease in the value of one variable corresponding to a decrease in the other, the correlation is positive. That means both the values are increasing or decreasing, then the value correlation coefficient is positive. If an increase in the values of one variable corresponds to a decrease in the other, the correlation is negative. That means if one is increasing, then the other is decreasing, then the correlation is negative. This is how the positive correlation and negative correlation can be defined. Next, calculation of this correlation. This correlation can be calculated by knowing the coefficient of correlation. This coefficient of correlation is the numerical measure of correlation. So, the numerical measure of correlation is called the coefficient of correlation and is given by R is equal to sigma xy over n into sigma x sigma y. Here this sigma is a summation. R is equal to summation of xy over n into sigma x into sigma y, where this x is equal to deviation from the mean. X is equal to x minus the mean. Then this y is equal to deviation from the mean. Y is equal to y minus the arithmetic mean. Then the sigma x stands for the standard deviation of x series. We learned that correlation means two sets of data are required. So, sigma x is the standard deviation of one set of series or x series. Then sigma y is the standard deviation of y series, where n is the number of values of two variable. So, using this formula we can calculate the coefficient of correlation. Next, lines of regression. You know the scatter diagram. In that scatter diagram, these lines of regression comes into picture. In the scatter diagram, the dots in the sense the non-fitable data tends to cluster along a well-defined direction, which suggests that a linear relationship between the variables x and y. So, in a scatter diagram, based on the clustering of non-fitted data, a linear relationship can be drawn between x and y. That linear relationship says the line. You know, the equation of a line is y is equal to mx plus c, where m is the slope, then y and x exist. So, that is a linear relationship between x and y. Like that, here also the linear relationship between x and y gives a line. Such a line of best fit for the given distribution of dots is called the line of regression. So, line of regression talks about the best fit of the scattered data. The best possible mean values of y for each value of x is the line of regression of y on x. So, the best possible mean values of y for each value of x is the line of regression of y on x. Like this, the line of regression of x on y can also be defined. That is, the best possible mean values of x for each value of y is the line of regression of x on y. This line of regression can be numerically learnt by knowing the regression coefficient. So, regression coefficient can be for x and y. So, here we learnt that the line of regression of y on x is the best possible mean value of y for each value of x. Like that, the line of regression of x on y is the best possible mean value of x for each value of y. Like that, the regression coefficient of x is equal to r into the standard deviation of x over standard deviation of y. The regression coefficient of y is equal to r into standard deviation of x over standard deviation of y. So, whose regression coefficient is to be obtained, that component standard deviation should come in the denominator. Like that, you can remember the formula for the regression coefficient. So, in this lecture, we learnt about the standard deviation and variance, then correlation and regression. Standard deviation is the most powerful measure of dispersion. How much data is deviated from the mean value can be learnt by calculating the standard deviation. Then the square of the standard deviation is known as variance. This variance can be numerically measured or calculated using the coefficient of variation. This coefficient of variation is the ratio of the standard deviation to the mean. Then correlation, that is another concept we learnt in this lecture. This correlation is the phenomena connecting one variable with other. Then line of best fit for the given distribution of dots is called line of regression. So, line of regression, coefficient of line of regression of x, all these things we learnt in this lecture. So, after listening to this lecture, you can answer the following questions. Define standard deviation, give its formula, explain the correlation concept. What do you mean regression? Thank you.